Today we are going to talk about Riemann sum. And then the scientist that proposed it is Bernard Riemann, the scientist over there. And then what's the use of this? One may ask. Now, apart from integration that we use to find area below curves, Riemann also proposed a way to find the area below curves. And I am going to explain that in this video content. So follow me through and you get to know the details about Riemann sum. To the concept. Riemann sum consists of two sums. And first of all, we have the left sum and the second one, which is the right sum. Left sum and the right sum. Now, the left sum gives us the underdose approximation of the area below a curve. The left sum gives us the underdose approximation of the area below the curve. Why? Because these rectangles are not giving us this area, and which is below the curve, but it's not giving us. So this is why we call it underdose. Let me write the name at the other side. Underdose for figure A. Underdose approximation. And the other one, which is B, is overdose. Overdose approximation. So the same thing. Approximation. So now it has extreme ends, and the extreme ends we are naming them A and B. Now let's talk about area of a rectangle. And we all know the area of rectangle, easy peasy. So let's just say it. I hope you said it right. So the area of a rectangle is equal to the width, which we denote it by W, and then times the height. Now for this curve, note these curves are the same. Don't say because the diagrams look different, so they are different curves. They are the same curve. It's just that I made mistake, so the curves are not the same. In actual sense, they are the same. Take note. So it is the width times height. And for this function, that's this curve, the width is change in x. And I'm about to represent it for you. And the height is f of x. And then the x can change. When x is 1, you find the height of that one, f of x1. And when x is 2, you find the height of f of x, which is 2. But the change in x doesn't change. They are the same rectangles, but the only thing that is changing is their height. So the change in x will remain constant. Okay, so now here's the change in x. Now let me clear it. Note, for the Riemann's right hand sum, we start doing the triangle from the right hand, and then if you will draw a line that will touch the curve. So it touches the curve here and then moves in this direction to any width, and then come back to the line itself. And then you start from the same point, and then you map it to the curve, and then take the same width and then come back. So that's the format you have to take. For the left hand sum, we start from the left. So this is how it looks like. It hits the curve and then bounce back to a width, and then comes down to x again, and then moves up again as usual. So take note. According to Riemann, he said that the sum, that's the sigma of I. The I there is just a dummy variable. It can change. The I there is just a dummy variable, and then to n, sum of I, which is equal to 1 to n of what? F of xi. I was saying that the I there is a dummy variable. It can change. It can be 1, it can be 2, it can be 3, and so on. And then change in x. That's the width. And then this will give us the height. So basically, you can see the analogy that Riemann used. He was finding the area of the rectangles and then summing all the individual area of the rectangles to get the area below the curve. This is the analogy that Riemann was using. This is it. Riemann's sum. This is how it's done. Now we'll take some. Forget. I nearly forget. Now after doing all the Riemann left sum and the right hand sum, now it doesn't give a right approximation. It gives you false approximation. But if you want the approximation of the actual area which we'll find using integration, when you want to get the approximate of the actual area, it's just the average of the average. Let me use white, color white. It's just the average. So the average of the Riemann's left hand sum. So let's denote it by S sub L plus Riemann's right hand sum all over 2. So this is it, the average of. So this will give us the approximate of the actual area. And now the change in x. This is the formula. You note from the figure in the previous page to be the two extremes that we have. That's A and B. The two extremes that we have, A and B. So it's the difference between the upper extreme, that's B, or in integration called the upper limit, minus the lower limit, which is the lower extreme, A, divided by the number of rectangles. So the number of rectangles. So for that rectangle, we have 4, but we will not write it here. Let's just represent it by n. So this is how we get a change in x. Take note. This is how we get a change in x. It's also another formula to note. And this also another formula to note. So let me clear them and then put a question on board. Now let's take this question. Solution. What does the question say? It's saying that find the area below the curve f of x squared, below the curve f of x, which is equal to x squared, using 4 interval or rectangle. And it's obvious from the question. They are saying 4 interval or rectangle. So obviously n will be 4. The number of intervals or number of rectangles will be 4. And now function f of x was given in the question. F of x, which is equal to x squared. And sorry, they didn't give the two extremes, but I'll input my own two extremes. So let's use A, the lower limit, to be equal to 1, and then the upper limit B to be equal to 5. So the question didn't give, but I have to use these values. Just don't freak out, because you can every question comes with the interval. Even from integration, you know that it will give you interval unless it's indefinite integral. And now the more the rectangles you draw, the higher the approximation becomes valid. The more the rectangles you draw, the higher the approximation becomes valid. So let's tabulate our data. This will be our x values. So the x values and then our y values. That's f of x. The height. So it will be like this. Now for x1, we are doing Riemann's left sum. So we are doing Riemann's left sum. Riemann's left sum. Okay. So let's go back to our previous diagram we drew. So Riemann's left sum, we do not include the x5, the upper extreme x, which is b, its x value. We do not include it. Why? Because x sub 4 is the same as x sub 5. They have the same height because the same rectangle, they have the same height. So if you repeat x5 again, it's like we are finding height, double the height. It's like 2 times the height and then times the width, which is not appropriate. That's not the area of a rectangle. So we only take, we ignore this part. X, ignore x5 for the Riemann's left hand sum. So let's move on. So we only do the x1, x2, and x4. Let's move on. Let me move on to the next page. Now, x1. Who can tell me x1 just by looking at the question? Well, I guess you get right. X1 is the same as, for the left hand sum, x1 is the same as a. So x1, which is 1, a is 1. That's why x1 is 1. And now 1 squared. The function is saying you should do the square of the x. So 1 squared, which is 1. And now let's find the interval. Let's find the interval so that we'll know the subsequent x values. So the interval change in x. We said earlier that it is the upper limit is b minus the upper limit, that's upper extreme, minus the lower extreme, that's the lower limit, a, divided by number of rectangles or number of intervals. So we are using n equals 4. So this time n is 4, but the upper extreme is 5 minus 1. So we have 4 divided by 4, which is giving us 1. So we are getting our interval or the weight between them to be 1. Okay, so let me clear this thing from them. So we have our change in x to be equal to 1. So our change in x is saying that it's 1. So when we are moving on to x2, we add 1 to the previous one. So the previous one, which is 1, we add 1 to it, we are getting 2. Now f of x is saying that we should square the x value, and this time around the x is 2. So if when we square it, we get 4. And then let's move on. Now note, we are doing up to x4. We are doing up to x4. So when we get to x4, we stop. x5 is not included for the left sum. Okay, so obvious 3, and then 3 square, which is 9, and then the last part is x4, which that one will be 4, and the squared will be 16. So this is how the table will look like. So we want to get all our data before we start with the question, answering of the question itself. So this is our data. So by the formula, sigma I equal to 1 and then 2 and f of x I change in x. Now since change in x remains constant, it doesn't change. So let's bring it out and then let's perform the sum. So it will be something like this: change in x and then sum of their heights. That's f of x I. Sum of their height. So I is equal to 1 and then n f of x I. Okay, so now let's substitute our value into it. So our change in x, which is 1, and then times the sigma. So we are summing them. So our f of x values, we have 1 plus 4 plus 9 plus 16. So let me take my calculator and do this quickly. 1 plus 4 plus 9 plus 16 going to give us 30, and 30 times 1, which is 30. So 30 units. So this is the lower approximation. 30 units. Riemann sum. Let me denote it by SL. SL. Reimans left hand sum. So now let me clear it. Put the value somewhere so that we'll use it later. So Reimans left hand sum is giving us 30 units squared. So it's area, so we have to note the square. 30 units squared. So now let's do the right hand sum. Right sum. Okay. Now for the right sum, let's move up. Let's move back to the question itself. Let's move on back to the figure so that we know how to do it. So now this is the figure. For the right hand sum, we ignore the x5. That will be on A. But we'll take the x1. Sorry to put it there. X1, which is on the B. Take that one. X1, which is on the B. So that one will be the upper limit, the x1, but we ignore the x5. It's because x4 and x5 are the same, have the same height. And then when we include them, the formula will be wrong. So let's take note of that. Okay, so the right hand sum. So that one too, let's draw our table. So the right hand sum will be, let me clear this table to be, it's a different table altogether. Let me clear this table. Hope it doesn't clean everything. But if it cleans well, you can still manage to bring it back. Okay. Okay. So SL would give us 30 units squared. Let's do the tabulation for the right hand sum. Now for the right hand sum, this is the x and this is the y, which is equal to f of x. So now x1 we said earlier when we went to the previous page that it will be the upper limit because you are starting from the right, so it will be the upper limit. So x1 will be 5, and then f of x, let's do f of x, which is x squared. 5 squared. Yes, in this case it will be 5 squared, which is 25. And then let's move on to 4. When x2 will be 4, so 4, and then 4 squared, which is 16. x3, which that one will be 3. Note how we are doing the change in x. We are subtracting it from when we move on to the next, the next one. You subtract 1 from it, so it's decreasing by 1. 5 decreases by 1, and then we get 4. So that's how it looks like until x equals 4. That's x equals 4 to see how the value of x will be. So when x is equal to x3, when x is x3, the x will be 3, and then the square root of 3, which is giving us 9. And when x is x4, that's that one to subtract 1 from it to be 2. So the square root of 2, which is the square root of 2, which is 4. So this is it. This is it. So now let's use the formula. So we are not going to write the formula again, but formula view. So the right hand sum, that's the right hand sum, SR, is equal to change in x and then times the sum of the x values. So the sum, that's f of I1 plus f of till x4. So let's continue from our the values they give us, and the ones to be found, let's input them inside. So change in x, which is 1, and then let's sum the values. So f of x, which is 25 plus 20, 16, should be 16, and then plus 9, and then plus 4. Let me input it into the calculator. 16 plus 9 plus 4. 54 times 1, which is equal to 54 units. Okay, so squared. So let's do the average approximation of the actual value. So the average, which is will be equal to SL plus SR divided by 2 is equal to 30 plus 54 and then divided by 2. Okay, so let's do that one too. 30 plus 54. Answer divided by 2. We are getting 42 units squared. We are getting 42 units. Let me write it for you. 42. Now take note. I'm about to confirm the answer using integral. Integral, the upper limit and the lower limit was given to be a equals 1 and b equals 5. So integral from a to b of f of x dx is given by this a, which is 1, and then 5, and then f of x, which is x squared dx. So now when we integrate this, you are getting something like this: x to the power 3 all over 3, right? As in this integration, the power, you add 1 to it and you divide by the sum of the power and 1. So this is what we get. So now don't forget the limit: 1 and then 5. So let's move here and do that one too. So when we let's put 5 in it first. That's how we do it. So 5 cube and then over 3 and then minus, that one should be 1 cube all over 3. So let me input all into the calculator and get the answer: 5 over 3 divided by 3 and then minus 1 cube divided by 3. So let's see the answer. We had our answer to be 41.333. It's reoccurring decimal, and even this one, if you approximate it, it will be close to 42. So you can see that the answer are similar, but Reimans sum is not given as the actual one, so don't say it's wrong. It's just the approximation sum of it. So the approximation sum of the actual value, which we get from Riemann, was this answer. And then for using the integral, we had this is the actual one. There's no big difference in it. The difference is just small, so it's the approximate of that. So that's it for today. Bye.